and I found this Raylib, which is kind of cool. So I guess if somebody doesn't know what we're talking about, so it's kind of cool because I think it was made by like some teacher that wanted to teach, like game programming, uh, in a simple way. So it's basically just a library that lets you, it's supports like all the platforms. Although I think it doesn't support iOS for some reason, which feels very weird because it supports macOS. So I don't know what's the real difference, you know, unless it's some issue with OpenGL or something. But I think I don't know, feels weird. But anyway, like it supports all the platforms, and then it's written in C, so you can have language bindings for everything, which is what we're working on. Some of these language bindings are, properly maintained and all that stuff. And the Swift one, there is a couple of them, but I think the one that it's mostly maintained is this one from this user, which has a bunch of game-related things in Swift, which is pretty cool. Like I recommend you to look at the stuff this guy does. I think he has a YouTube channel. Yeah, whatever, YouTube. Yeah, so like this guy has a bunch of cool things. Like all of this is written in Swift. He's making its own custom engine and all that stuff, which is pretty cool. So yeah, he has this, but it's using 3.7 and Raylib it's at 4.1. I don't remember now. So just for the sake of learning, I spent yesterday and a bunch of time trying to update the library. I tried to make my own Swift package and start from scratch, but it actually was harder than I expected. So instead, I just took like a fork from his work and updated the files and all that stuff. And that's what we have here, which I think it would be nice if we made the PR. I'm not sure if the guy is going to accept it because I didn't fix everything. Like there is some things that, you know, there is some things I just removed, like commented, because I'm not sure what's the new version. And the problem is that Swift it's good with C at to a certain point. Like I was showing you here, like enums are exposed as structs with raw representable conformance, but you don't get the cases. So you need to write the cases yourself, like I was doing here. So there's a bunch of kind of like manual work you need to do to expose these things, which this guy has been doing. So I'm not sure how much of that, he has automated. Because I will expect, like, if you really want to maintain like basically, how is it called, a language binding, you are better just automating that, right? And as I was trying to do now, they even have a parser. So they have this parser that parses the C headers and exports like XMLs or JSONs, like whatever you need. And from that, you can generate a proper language binding. But I tried to do it with this library and it doesn't work, which is a pain. But yeah, so that's what it kind of is. Like for me, I mean, like it has a bunch of cool gaming stuff, but for me, one of the cool things is that it just lets you manipulate Windows in a multi-platform way. So you can just open a window and start rendering stuff in it, which, yeah, as you say, there is other libraries as SDL, and there is a bunch of them. But I found this one very easily, and since it's a little bit focused on games and kind of small tools, it has also a bunch of math and audio. And the one I was trying to use is this GUI stuff, which it's inspired by an immediate mode GUI API, which is pretty cool because it has a bunch of stuff. It even has themes, so you can customize it and all those things. Like it's quite full featured, and it's not Swift UI, but since it's an immediate mode API, it's super easy to use. Like you don't have to learn pretty much anything, and it works on all platforms. So with this and being able to compile Swift in Windows, I mean, we can make a Windows application. Shouldn't be a huge deal. And that's something I've been wanting to do for a while, for like kind of like small tools and applications that I work on. So that's handy dandy. Let's try to port some examples. So you see, example So this one, it's easy. It's just a basic window. Just proving that you can open this window. And I guess the question is, how can we structure this? Because he has this example, which is the, it's the snake game, which is, pretty cool. It's taking, yeah, there you go. So this is the snake game in Swift using this Raylib library, and it's multi-platform. So you can run this on Windows, Linux, just works everywhere the same way. Then you cancel. There you go. So I would like to have these examples ported, and they are quite simple, but they help a lot. And that also help us, But there is multiple ways of doing but I don't really want to create packages for all of this. So what I'm gonna probably do is just write the example for each case. By the way, the library is also WebAssembly compatible. So if I'm not mistaken, I don't know which one to show. Input mouse. This, yeah, it works on the browser with WebAssembly because it's a C library. For Swift, could be done because there is WebAssembly support in a Swift fork, so you need to install a custom toolchain, but it could be done. I just haven't spent enough time. But it's something that eventually we should look at it. But let's start with this one. So basic. I guess I can take just the same names and put here a file, core basics window. And I guess, to be honest, we can just test example, just press blah, blah, blah. Yes. So you don't need pretty much anything. I can just quickly write it down. So let's make, okay, so to start, I'm just gonna start doing a new window. So everything from the library, it's in the Raylib namespace. And it's, the first letter, it's lowercase to match Swift naming conventions. But if you look at it, it's what I was saying, that it's kind of a pain in the ass because it's just calling out to the C implementation. So it just renames the letter. And the other thing it does, it takes care of passing a Swift string into a C string, So these are the kind of conveniences you want, because you could just do this, but doing this everywhere directly, it's a pain in the ass. So, you want to at least pretend that it's nice in Swift. And then for this, so let's just do a screen width. And the thing is that you need to declare it as an int32, which is a little pain in the ass. I'm not sure if it will I guess if you're doing game development, you want to be a little careful about the types, but really, especially since originally this was designed to be as a teaching tool, I'm not sure you really care about the int32. I would just make this as integers and that's it, because it makes it easier. But anyway, so this makes a window with a title. So we can just put the title here because I want this example to be the same one as in C. So this opens a window, right? And if we run it, okay, let me see what happened. Expressions are not allowed in the top level. Yes. Okay. Because I'm not in the main. That's gonna be a pain in the ass. I guess I need to put all of these. I probably need to put this in a function with the example. thinking if there is a better way of doing that. And I don't think so. Let's do that for now. Core basic window example. Okay, let's just pretend all of this is the global scope for now. Okay, so there you go. So now instead of calling the snake game, we call the core basic window example. And if we run this, you're not gonna see anything, because basically as soon as we start it, it just closes. But you can see that, you know, it loads all the modules. So core, OpenGL, shapes, textures, text, models. So you can even load 3D models and all that stuff, which I'm not using, of course. The audio uses the Metal API. That's cool. And the device, which is basically a display, they call it device because it's like kind of like the graphics, you know, way of naming things. And we have a display size, the render targets, open. Okay, so we're using OpenGL. All that's cool. But you can see that after all of this stuff is done, we even have fonts and all the stuff. Then pop, we close, which makes sense because I mean we're not doing anything special. So the next thing we need to do is we can set a target FPS, you know, to 60 FPS, which is kind of like the standard in games. Do I want to keep the comments? Yeah, why not? Why not? And I guess we can do this too. No, I'm not sure if I mean let's try, you know, like I mean I just want this to be like a useful resource for people. So, you know, let's just try to keep these comments. Okay, but now we get into the main game loop. So how do you actually make it so the window doesn't close? That's very easy. So you do a game loop and basically you close the window when there is a method on the library which tells you window should close, which basically checks for the key escape. So I mean this method, like it's quite easy to re-implement the escape. The close icon pressed, I'm curious, and to be honest I'm gonna check now. But if we do this and we run, you know, I'm not sure we're gonna even see this because there is nothing, like we're not rendering anything, so there is no window in display, right? So to display something on the window, we need to call this begin and end drawing, right? So let's do some drawing. Raylib. It's a pain in the ass to do Raylib all the time. That's why I'm not so sure, like, you know, what's the best way of like actually wrapping libraries like this? You probably want, at the end of the day, you probably want to make a proper Swift library that follows kind of like the same style, but it's full in Swift, and you forget that Raylib even exists. You know, I guess that's a proper thing. Because here, even like you probably like, I don't know, you know, like I could imagine like if you look at how, you know, Swift UI or even like Core Graphics does it, you probably want the context here that you draw into and things like that, but you know, whatever. It is what it is. So now we are drawing, we can actually do a clear background, and there is some colors. We're gonna use the same they use. And again, this, it's not automatically converted from C. You know, these colors are defined on the Swift overlay. So there is that. And finally, we can draw text. And this draw text, it's basically part of Raylib itself. It's not the UI side of it. So you're drawing text kind of like in the sense of a game. You're just drawing fonts directly and stuff like that. The UI side of it is more structured, like you don't draw text, you make a label and a button, stuff like that. But for the simple thing we're doing here, you know, in this example, it's just like, okay, you can just draw the text. And then for the position, I mean, we can just hardcode the positions like they do on the example, and the font size we can say 20, and for the color we can say light gray. End drawing, so this will end the drawing. The drawing starts here, you can do everything. This kind of prepares the graphic context from Metal or OpenGL. Then you can draw whatever you want, and then you can end the drawing. And finally, I mean, it doesn't really matter, I think, because when the process starts, the window should be closed automatically. But we close the window. So there you go. So we have now this window, was pretty easy to code. And you have a place to render and to do everything you want. And basically you can start making games with this. And this works on basically all the platforms that we mentioned, which is pretty nice. So let's just go through this and, let's put some comments. I don't think I like this one, That's just my preference. Yeah, and basically here, it's the typical game loop. So freeze till you update and then you draw. In this case, there is nothing to update, but we can do the same as they do, and we put a to-do here. Even Xcode should show the to-do, which is nice, and then we do the draw. Now we can see here how they kind of pretend that this is a graphic context, and that's why I kind of like will do, like I will imagine like an API that's like Raylib, draw, and then you open this, and you don't have to begin and end, like this does it for you automatically. But that's maybe too much. So here you draw, there is no comments here, no? There you go. And then we can put the initialization here to close the window. And we don't have to return because that's kind of outside of, like that, you don't need to do that in Swift. Okay, so I think we have this one working, right? Very annoying because it prompts it on the other screen all the time. This is the main screen. Cool, that's cool. If anybody has any questions, feel free. Feel free to ask. Cool. So what I'm gonna do is say this core for basic window example. Oop. That's nice. Okay, so now what I'm gonna do is duplicate this one because they are pretty much all very similar. So we can duplicate this one and go to the next one. And I can close this. Okay, so the next one, it's a title screen, which is kind of the same, I think, for basic screen manager. Oh no, I haven't actually looked at this one. And let's do this. And I'm tempted to not rename this because it's gonna be a pain in the ass, but whatever. Did I say example? Yes, because I just want to make it harder for me. And then we go on main and we comment this one and we put this one. We're gonna keep doing this for now. I could imagine making something easier than this, but it works. Sorry for the off topic, but I remember one of your videos about bringing processing to Swift. Oh yeah, it is. I wonder if yeah, I actually was thinking about that because like the other day I think I wanted to link. No, it was not the other day. It was this morning. I think I tweeted a video of mine, and I actually was like looking at the list. And yes, I saw the processing video and I actually thought, oh, that's not a bad idea. The thing is that I haven't used processing a lot myself. So I don't have a feeling for the kind of API that you wanted. That said, I don't think you need to actually mimic P5's API, to be honest. Like, I think you can go for something more Swifty, right? Oh man, that's old. I was in London back then. Lol. But, having something like Raylib can make things very easy, To be honest, I mean, let's be honest, like, eventually, I wish like Raylib was necessary, and we will just do that, all of that in Swift. Like if you look at the Rust community, they should implement everything, man. Like they are not scared of doing, touching windows and talking with graphics APIs and all that stuff. It's here in Swift that we are, we're afraid of all that stuff. But anyway, no, I think it's a very good idea. Like I think somebody should embark on that project and do it. Okay, what is okay? So this is just changing screens. Okay, cool. I think it's a good example to work on. Let's try to rewrite that in Swift then. That's cool. Cool. So how does it start? Types and structures definition. So it makes a game screen. Okay. That makes sense. We can put that here. So here is where you make like all your data, all your gaming things. So in Swift we can just do game screen, and that's gonna be an enum, and then we can say logo. We don't have to give it like not enum case. And then you have the title, and I mean we could write it in line like they do in C, but I don't like that, so I'm not gonna do it. And ending. Okie dokie. So there is that. Then we have the size, like that's the same thing. We initialize the window. Let's change the name, the title of the window. And we put the FPS here. I'm just gonna put it there. And then we will have, I guess we're gonna change it, so let's make it a bar. So we have a current screen, which is a game screen, and let's start at the logo, right? Yeah. Okay. Initialize all required variables and load all required data here. Okay. Kind of weird that to do it before, so let's put it kind of like here. Frame counter, useful to count frames. But didn't they have already a delta time thingy? Delta, was it time? Yeah, get time. Yes, you get frame time. So I guess that's the time of the frames, but it doesn't. Yeah, okay. Returns the time in seconds for the last frame drawn. That's basically the delta time. Which I mean, if you have done any kind of game development, that's on every framework or engine. So yeah, but yeah, okay. I guess they want to count that. Useful. Okay. I mean, if you say so. Let's just do this, and do this. Useful to count frames. Okay. The FPS, I'm gonna put it here because I think it makes more sense to initialize the window things and then initialize your things. That's just me. So I'm diverging a little bit, from the example, but I think it's worth. So here is the same thing and on the update. Cool. So here's where the update logic is. So let me just skip it over to do the drawing. The drawing, it's the same thing. Draw logo screen. Yeah, I mean, of course. Okay. And then this thing. Yeah. So okay, they are giving you it's basically an example. So you can take, it's kind of like a template. You can take these and you know where you need to put your things. Okay, that's good. You see that it's very nice to learn. Like that's what I like about this kind of library. So let's switch on the current screen and Xcode will autocomplete this for us. So if we're on the logo, we increment the frames counter. Good. Frame counter +1. Count frames. Wait for 2 seconds before jumping to the title screen. Okay, I see. And then it checks for the key presses inside. Okay, makes sense. I see what kind of example they are trying to do. Okay. So let's just copy this. And we can do an if frames counter. It's more. Thing is, I wouldn't do it like this. Seems like a bad practice because it's like 2 seconds at 120 frames, and that's not true, really. I mean, we're saying that to redraw the screen every 60, like 60 frames per second. But if for some reason it can't do it, I don't know, like this, the computer is very fucked up. You shouldn't be counting frames. Like you should take the delta time and keep incrementing the delta time until it's 2 seconds or whatever. Let's just follow the example. So we see, so basically this is kind of like a state machine. So then on the title, they want us to press enter to change the gameplay. Okay. So I think this is Raylib is keep pressed, enter. You see how we already have all this, very nice. And then we have the Raylib is gesture detected, tap. There you go. So it works on mobile too. And the current screen then switches to the gameplay. Okay. So then if you're on gameplay, they want us to press enter again to change to basically end the game. So we can just do this, to be honest. Same thing and ending. So that's the same thing. And then when you're on the ending, we go back to the title. Okay. We go back to the title screen. And there you go. And we don't need any breaks because Swift doesn't fall through on the cases by default. And we don't need any default because this switch is exhaustive. So you can see that even if the API it's not very Swifty, it's still nicer than C. Okay, so now let's do some drawing. Let's start by clearing the background in this like off-white color. And then instead of doing this, we're gonna switch on what's the current screen. There you go. And like it makes like there is probably some people screaming, "Oh, why are switches? Why you don't make a different object for each screen? And then you call draw on that object and update on that object." And it's like, I mean, first this is an example, And then yes, if you start making these screens have its own logic and state and all the stuff, then yes, like you're gonna start breaking it down. But also, to be honest, I think that's just too much object-oriented programming mindset. I think this is nice as it is, and there is not much else to worry about, to be honest, But, everybody thinks differently. So draw the logo. Like, we can actually do that, but, I want to just write the... example. So let's do this. Oops. 40 light gray. Cool. And then you wait for 2 seconds. And these are 290, 20, and this. And let's see if we're actually doing things correctly. It's been too much time without seeing anything on the screen. So let's give it a run and see, like, logo screen, wait for 2 seconds, and now we're on the next screen. But we're not drawing anything. But if we click enter, I will expect that if we click enter, eventually No, because we haven't drawn the title. We're still on drawing the logos. Okay. To be honest, I can just copy all of this, and just say Raylib draw, and this is green, this is dark, what is it? Dark green. I'm missing this. I know, I'm missing also a dark green. Is this working? That should be fine. Okay. So let's do the same for this. I don't know why it doesn't copy that. Let's do this. Okay, so let's take this and say Raylib draw. So all of that is the same, but this is purple, this is maroon, and this is also maroon. Okay. And now let's do the ending. The ending screen. So we just remove this. And we do this. Right? And now we do blue and dark blue. Dark blue and dark blue. And that's it, right? That's basically the entire thing ported over. So if we run it, 2 seconds. Now we're in the title screen. Press enter or tap to jump to gameplay screen. Gameplay screen. Now here we have our gameplay. Oh, look how fun it is. So much fun. And then you are on the end screen. And if you click retry, it goes to the title again. And it just keeps cycling. There you go. And if you click with the mouse, it also works. There you go. So that's another example done. That's another example done. The core. That is nice. One thing I wanted to check was this. How does this guy check for escape or close? Wait, where are we? Hardcore. Sorry, I didn't see the function continue. I saw this return and I immediately thought like the function ended here, but no, like this is for the web. So on the desktop, if core window is ready, well, the window is minimized, stop looping execution. I see. But wait, does this? Wait, there is no. Okay. Platform wait events. And then it pulls. Yeah, and I'm just thinking that, because so it's like on every loop. So let's go back here. Wait. So here we are just doing a loop, it's the game loop. And we call this function. And this function eventually goes here, which is the window is ready, which, has been initialized, that's fine. And then it goes into a loop checking for events, which makes sense because it's like, well, it's minimized. it doesn't want to run the game loop, which I guess, okay, that, I mean, makes sense. But depends on how you implement this. It will mean, you know, like I guess we can check that if we go here, CPU, I mean, yeah, fucking Chrome. I guess this example what we're looking for, yes. Yeah, so I guess it doesn't do anything. And if we minimize, does it go down? Yes, it goes even below. Okay. But I'm not sure if this loop is going all the time or it's just waiting for an event that it's triggered when we maximize. That's the bit I'm not fully understanding. Because wait events, platform events, and then it does this. I want to pass the node to the kernel. You know, and then it polls. There's a for loop here. Yeah, I'm not sure I understand that part. Anyway, the point is that eventually the should close is what we are looking for. So it's actually, yeah, you pass the window handle, and this window handle, okay. So I guess the window handle is like a pointer to an OpenGL window, and then I imagine that when you close the window, that gets to, I don't know. I know the window itself has a should close. Okay. So is there somebody assigning this? Input window close. Okay, so there is a callback. Yeah, so there is this callback that it's passed depending on the platform layer. Okay, see, application should terminate. Passes this or the window close. Yeah. So when the window is closed, you pass this to. Okay, yeah, see. Okay. So that's the nice thing about having this library. Because we could write this in Swift, and then it's like, yeah, that's easy for Cocoa applications. But then if you look at the Windows one, it's like we also need to learn how the Win32 API does it, which is kind of like more gamey, to be honest. Like, I think we're too use of the nice APIs that Apple gives us. Because, like, look at this. Like, the fuck is this API? It's like, yes, I mean, it's easier to understand and everything, but it's like see weird see things, you know? And instead, for us, it's like, oh, I mean, it's still Objective C, you know, but, you know, it's nice. I don't know. It's like the delegate pattern and all the stuff on Apple platforms is too nice. But okay, at least now I understand how they do this, which is the whole purpose of this, to learn how this works. Cool. So that's another example now. Let's take a look at what's the next example. And again, between the examples, you know, like I'm reading the chat, so if you have any questions, just throw them there. Maybe I can answer them, maybe not. Maybe. And now the next example, it's about, I think there is some more gamey things. Like you're gonna start see how you can go from here to do some gamey stuff. So yeah, it's about, you know, moving this ball on the screen. So we start again with the init on the screen, and then we change this title. FPS. And now let's, okay, so here we're gonna have a ball position, and this is gonna be a vector 2. and we can initialize it with x and y. Screen width divided by 2, screen height divided by 2. And we can just do this. Okay. So now let's do the update. So Raylib is key down, and with the right, then we can do ball position x2, and we basically need to copy paste this for left and minus. My god. And then top down, and we change this for y, this for y, and the top. Sorry, this is up. Okay. So now we get the input and we're updating the ball's position. And then we should render this. We put this text. So we put the text here. And we put it at the top, basically left corner. We make it visible. And then we draw the ball, which is basically just a circle. Draw circle V. Yeah, that's one of the things that this API, you know, like when you are using C, it makes sense, but in Swift it's a little confusing because we have all these different draw circle methods. And for example, these two, I will expect them to have the same name. You know, but in C you don't have method overloading or function overloading, so you cannot do that. So you need to use different names for it. You know, that's kind of like, you know, a little weird, but anyway. So we have the positions here, and we make a 50 of radius, and that's it. Everything else is the same. Wait, what? Oh crap, I did again. I changed the example. That was not the correct one. Okay. So I'm just gonna do that and go to input keys. Let's try again. Now it's working. So we have this ball here, and if I use the cursor, I can actually move the ball around. You see? And because I'm drawing the circle after the text, it draws on top of it. There you go. So you're gonna start seeing how you can get input, and with the input change the UI, the graphics, and you can do pretty much whatever you want with it. So that's another example. There you go. Core input. Cool. Let's go. And this one is the same, but with a mouse. So I think that's gonna be quite easy. It's gonna be simple. It's annoying because Xcode always messes up with this because it doesn't select the file. Okay, mouse, and we probably want to comment this and put this here. And I think this is literally the same example, just that they say mouse here, 60 FPS 2, the ball position, for some reason they make it start at -100. They put it outside the screen, but as soon as you put the mouse in, you know, it gets rendered in the screen. And here they have a ball color, which is a color dark blue. Okay, 60 FPS. I always do it after the call to the window. And here the only difference, so first all this thing gets just basically removed because you can just do it with a mouse. So you can just do Raylib get mouse position. But then we have a bunch of if checks to detect presses of the button and change the color of the ball. And now this, for some reason, it's reversed. So this is the same, but now for some reason it's 40 and it's ball color. Okay, so I mean, if we run this, we will see the ball move. You see, but it doesn't change colors. Move the ball with the mouse and click to change the colors, but we cannot click. So now let's do this part. This mouse button pressed, and we can do the left mouse, and ball color we set it maroon. And here we did the else if for the middle mouse button, and we put it lime, and then the right, and we put it dark blue. So we did these ones. Now the thing is that I'm not sure. But color is a red constant. Yeah. Like I'm not sure. There is more defined on the Swift overlays. So side is not there. And we should say purple. And then we have extra. See, but all these buttons are not defined. So maybe we could define ourselves. And then we have extra forward. And in any case, I don't have these buttons on this mouse. Forward and back. Like on the mouse that I have on the Windows PC, I do have them. So maybe I will have to switch to that. And the one is beige. Okay. So then we need to implement this. So let's just give it a try. I mean, it should be easy. Well, here we see this part. Okay. And then mouse button cursor. Sorry, I was looking down. Yeah, left, right, middle. Yeah, so we can just to be honest, we can just take this and I want to copy this. Cool. And now with some edits, we can just get rid of this. Now we need to lowercase. My god, side, extra, forward, and back. And in theory, if I go back and compile, I should have them. I do have a couple of buttons. Let's see if they work. Okay, so we have the window here, and I can move it. So if I press the left, it's maroon. I mean, I call that red, but whatever. It's like a little, yeah, I don't know. Anyway, this is lime, dark blue, and then let's see which one is this. Okay, wait, what is the middle? Lime, yes. So that's the extra, and this is the side button. Extra and side, okay. Those are the two buttons that I have. I don't have more buttons. It's not a gaming mouse, so I don't have a forward and back. But on the other mouse, I have more, right, or not? No, I only have two more. No. So I don't have mouse to test the forward and back. But anyway, you get the idea. You get the idea. Cool. So that's another test done, even with an improvement on the mouse button API. So I think I may commit the mouse button into master, to be honest. So let's do this. Let's do this. Core underscore input mouse. I'm gonna commit this. I'm gonna switch to master. Stash and reapply. Okay. And added all button to mouse button. Is the name on right? Yeah. Cool. And I can go to, now let's go back to the examples and let's merge master into it. So we're back in compiling order. Okay, cool. That's some work done. That is some work done. What's next? Input mouse wheel. Okay, the wheel. That should be also not that. That should be easy. So I think we can do it. Okay. So let's do. Oh my god. Like it's way easier to just go to Finder. You know. So by now all these examples are looking very similar, so I don't think it's gonna be a problem. Okay, so do we have mouse position X? Hola, ¿qué hace Eclipser? Hola, ¿qué hace? Screen height divided by 2 minus 40. Why? So that's the position. Why? Oh shit, that's true. Path of Exile is starting today. Okay, well, see you next month, friend. getting tired. Screen height by 2 minus 40 by position. Okay, so we're okay. Because it's the position. And this guy needs here's TP. Okay. So now the update gets even simpler because we just have the position Y. And now there is an API to get will move. Oops. And we multiply that by the scroll speed. And we negate it. Yeah, because I guess. Well, I'm curious about this because maybe they negate it because of Windows, but I'm not sure if this API takes into account the the macOS setting of reversing the scroll wheel. And now we're drawing a rectangle. Which version it is? The normal one, right? Okay. And yeah, I think this example, it's not updated. Screen width, I will have to cast it to float. Box position Y. And then the box is going to be 8. It's going to be maroon or red. Use the mouse wheel to move the... we're moving the mouse. And all this time I thought we were making it bigger or smaller because that's what I did in another example. So that's why I was not understanding the code. Now it makes sense. Okay. And here... Oh wait, text format? That's new. Oh shit, that's new. I haven't used this text format thingy. I mean, for now I'm just gonna do this. Let's make it work first. Ball position. It's not a ball, fuck's sake, it's a box. Okay. 80. And this needs to be an in32. Say what? What is this right now? This is an in32. Let's fix this one first. Yeah, this is a float, so this should be a float too. And now this is fixed, and now we need to convert this. No, we need to convert this to a float. Okay. And now the scroll speed, yeah, that should be a float too. Okay. And the scroll speed could be a let. Okay, so now if I do this, we have a box, and if I scroll up and down, we can move the box. See? That's cool. So now what I want to check is this thing, text format. That's 100% something that you wouldn't do like this in Swift, but whatever. So how do we do this? Draw text, and you pass a text format. That's not exposed. Yeah, that's not exposed at all. That's basically a C style of. Yeah. The fuck? Yeah, I cannot find text from my scope. Yeah, that doesn't fly. That doesn't fly. Yeah, it's on the C layer, but not on the Swift wrapper. It needs to be a C string too. That's something that should be added, but yep, not gonna happen. So for now, we should just keep it here like this. Okay. Well, this one is a little bit of a meh because there is this formatting thing that doesn't work. You know, like ideally, to be honest, like exposed to Swift, which like I would prefer to do it this way. Ah, no, sorry, I'm just saying bullshit. I thought we were changing. Yeah, no, nothing. I thought we were just for like because when I read text format, I always think like a formatted strings, you know, attributed strings. But that's not the case. This is just so you can pass. I thought this was to put the color to only this specific thing, but it's not that. So that's exactly the same thing as doing that. Okay, problem solved. Problem solved. So yeah, I'm gonna leave this screen, this example, like this, and moving on. Cool. So this was the wheel. So now the one I want to do before ending for today is this one. Because I'm curious to understand how the camera system works. So yeah, I switched to Finder to just do this because it's way easier. Okay. Create 2D camera example. So 2D cameras. Let's learn how the 2D camera works on Raylib. Okay, so first we define max buildings, which to be honest, I would just put this here. It doesn't make sense to. You know. I mean, it's local to this. Yeah, okay. That's C. We don't have to do that. Okay, 800 by 450. That is still the same. So let's say Raylib to the camera, because camera is always, you know, something that all these libraries that are not full game engines, like they need to answer properly. Because I remember using some old library, like for iOS, it was a pain in the ass to manage the camera. So I'm always curious how they do it. Let's see how they solved it here. So the player is a rectangle and it has it's 40 by 40. Okay, let's start with that, but we're probably gonna have to switch it. And then we have buildings, which is an array of buildings. I mean, buildings. So this is an array of rectangles in reality, and we want to start it, I mean, you know, with max buildings. That's why it's a define, because this needs to be a constant, but I don't think we need that. So those are the buildings, and now we have the colors of the buildings, which is an array of colors. And we need to, yeah, I don't know, just create a color. I'm not even sure we need to make this, you know. I mean, we're pre-allocating these arrays. You know, it's not a big deal, but whatever. And now we have a spacing of 0. Okay. So what the heck are you doing here? So for y in like from 0 to max buildings. I mean, let's do like this, because we want to iterate over one time. Yeah, I don't know. Like there is many ways of doing it, but let's you know, let's use this one. So the buildings at y. Oops. With equals. Oh, now we're using a random. Get random value. Yeah, that's the thing. Like we don't like we're in Swift, bro. Like I think we can use the standard library random, right? Yeah, there is no point on. So from 50 to 200. That's cool. See, now when you need to do things with the language itself and not, you know, operate with like the system, you can start using, you know, things from the standard library or even other libraries that are multi-platform. Pure Swift is the best thing, which to be honest is one of the main reasons why, you know, why the other communities do it that way. I'm still thinking I'm probably gonna refactor that, but whatever. Because I'm not sure I like this. But, you know, for now let's write it and then we can take a look at how you will do this in Swift in a better way. This can be this. And this can be like this. Okay, so those are the buildings and the spacing. We kept incrementing it based on the width of the building, and then the colors. We're basically making a color with random values. Okay. So red from 200 to 240, random in 200 again to 240, and also 200 to 250 this time. And the alpha, I cannot see, it's 255. Okay, I would like to do it this way. So let's wait, what the fuck? This should be a float. Yeah, because Swift defaults to int on this, and if you put 0.0, it defaults to double, so it doesn't work any other way. And this needs to be a bar. So this is just accumulating for this, right? Yeah, so it's just for disk. Okay. Okay, we're getting there. We're getting there. And now it's when we start playing with the camera. So we make a camera 2D. Okay. And then we say the camera target, it's a vector 2D with the player X position plus 20 and the player Y position plus 20. Why is it plus 20 though? Ah, because it's the size of the player, I guess. Yeah, because the size of the player is 40. So in theory, it should be target the center of the player. That's what it's doing. You know, so it should be width divided by 2. And player height divided by 2. I think that's what they really want to do. Okay, and then the offset. The offset is the screen width. So it's half of the screen. I guess that makes it so if you go does it loop or what? I guess it keeps it in the center, right? That's an interesting one. I'm not sure what the offset does exactly. But I think it's kind of like the size of the window you can move the player in. Yeah, no, I don't know. But I think it feels like this should let you, let the player move a little bit and you get into the edge, then drag it. It feels like that's kind of the intention, but I'm not sure. Rotation is 0 and camera zoom is 1. Okay. And now we write the main game loop. So yeah, player movement. Okay, let me just copy this. I think it's gonna be easier to do. So Raylib is key down. So if you go right, well, I said that, but there is a lot of shit in. And as I expected, the player needs to be R. So you move the player, okay. Now the camera target, we again put it on the player. Okay. And now the camera rotation, if Raylib is key down, A, letter A. Let's see, right. Okay, so this rotates the camera. Limit the camera rotations to 80 degrees. Okay. I mean, isn't there an absolute for this? Not an absolute. How is it called? Flip. How is it called when you want to keep the two values between a range? I don't remember the word now. Man, I'm getting tired. Clamp. Oh my god. Clamp. Cannot find clamp in scope. Is it clamp? Yeah, okay. So isn't that better? It's like the rotation, clamp it. The minimum is minus 40 and the maximum is 40. And you assign this to this. Isn't that the same thing? No, let's keep it like this for now. For me, Swift is such a good language in terms of strictness. Yeah, I mean, like, for me, I don't even call it strictness, you know? Like, it's just I want the type system covering my ass. Like, I want the compiler handle me code, not just letting everything go and then it's like, oh, things don't work. No, I want the compiler to be there helping me. Like, we're working together with me. So I love that. And the expressiveness, like, for me, it's one of the most expressive languages I've tried, you know. We don't see that here that much because we're using, you know, a C library. But yes, for me, like, and more things are to come with the generics and the type system improvements, all the stuff. Like, it's gonna be amazing. Like, Swift is one of the most expressive languages in there. Yeah. That's why I want to try it. Like, you know why I'm using this? Because I always want to do things with graphics and games and stuff like that, right? And then it's like, what are you gonna do? Unity. It's like, yeah, I like Unity. I've used Unity for many years. And it uses C#, and I use C#, and, you know, it's fine. I like it. It's like Java. It's all right. You know, I'm not gonna cry. And C# is very powerful and whatever you want. But after 5 minutes, I'm like, I just want to write Swift. You know, if I'm doing this for fun, I want to have fun, and Swift is fun for me. So that's why I've always trying to look for, you know, how can I do this thing that I like, but in Swift? Because I want to, you know, it's not that I want to learn other things. It's like it's the thing I love, you know. So I just want to have fun with it. So yeah, especially, yeah, like point free is like, it's amazing. Like, I cannot recommend enough. Okay, let's see if we can get this going. That's the same thing we did before. So it's just a Raylib, get mouse wheel. I haven't tried this here. So what does it do? Ah, it zooms. Yeah, sorry. I guess if I have the code. And we just what? Multiply to reduce the movement by a lot. Okay, so then this is the same thing. So we are limiting the camera. So we can do camera zoom equals Raylib. And don't we have a clamp in Swift, like in the standard library or something? Because it feels like no, I always have to import some third-party package. But yeah, I feel like that should come in the standard library. So camera zoom, and the minimum is 0.1 and the maximum is 3. Okay. So I think we can just read that. Because unless I'm very stupid today, that's what clamp needs to do. Okay, camera reset. Zoom and rotation. Okay. So if Raylib is key, press the letter R. So the camera zoom, we put it at 1, and the camera rotation at 0. And that's done. Okay, so let's go back here. What is the draw? So to draw, we begin drawing and we clear this. Begin mode 2D. Okay, this is where the magic happens. I see. Okay, let me write this crap first, because that's boring. So let's write this first. Okay. So first of all, I can't do it like that. Let's get rid of this. I mean, I'm just gonna be faster doing it this way. Okay. So this is a Raylib. Shit, man. So tired that I don't even know where I'm. And this and this and this. Okay. And now we need to change the names of the colors. So this is red, 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 red. Ooh, that fade thing. Ooh, I'm not sure what is that. Ooh. I'm not sure what is that. They're great, they're great, they're great. And yeah, we have a sky blue, but what is a fade? Really fade, really fade. Okay, that works. Ah, okay, that changes the color with 50% opacity, right? Return the color? Yeah, okay. I thought it was like some Funimation or stuff like that. Okay, so that's the drawing of the text. Okay, so now to do things with the camera, it seems like you create the object with the camera, and then instead of drawing on this level, kind of like on the graphic context, like if you were using this in core graphics, you will draw this on the graphic context. So instead of drawing on that graphic context, it's kind of like you open a new context, like a child context or something, for that camera. So that's begin mode 2D, and this is the same for 3D. And now you pass the camera. And when you want to stop drawing into that camera, end mode 2D. Okay. So now, as far as I understand, everything we're drawing here, I guess, it's basically shifted and like it's transformed. It applies all the transforms that come from the camera. So we draw a rectangle of, so that it starts at -6,000. So I guess if we walk that far, we will see, and 13,000, and the height is 8,000. That's kind of like a big thing. Okay, so that's kind of like a gray background. And then we go, okay, so we go for just gonna say building in this historians, and then we do a Raylib, draw rectangle rec, and the rectangle we want to draw is buildings of Y with the colors of Y, and that works. And then we draw the player. So again, Raylib, draw rectangle rec, and that's the player, which is just a rectangle, and let's make it red. This is red, this is not maroon. So I see the maroon and the red in the same way. Immutable, wait, what the fuck are you talking? I'm using it here. Okay. And now we draw a line to, it's kind of like showing us the perspective of the camera, I guess. So let's try to draw this. So we can do Raylib draw line. Okay, we don't need this casting or this casting. This is gonna be green. This is not needed. And as always, this fucking copy paste doesn't take everything. Okay, and you need to be a float, right? I need 32. Okay. I'm just gonna blindly cast everything because I don't have time now to look through it. Yeah, whatever you mean, bro. Let's cast all the things, and that's it, right? Yeah, so like when you're drawing here, and you're saying, oh, draw the player at this rectangle, so the rectangle of the player, you know, what is it? It's here. So even though we're saying draw it at this position, it's gonna be always offset and moved with the camera, right? So that's all what a camera is. It's like it's just a different coordinate system, basically, which kind of makes sense. And here you have it. So we can move right, left, right, you know, and we can resume. You see the city. And how did we rotate? I don't remember. Ah, with the ASD, right? Yeah. We're going up, we're going down. That's cool. And if I press R, it resets it. So then, what does the offset? What does the offset? Because we're not changing the offset, right? No, the offset is not changed. Add the offset. Wait, it says right, left to move offset. But that's kind of bullshit, not that explanation. Because you're not moving the offset, you're moving the target. Like the offset, it's not moved, you're moving the target, and then you're moving the player, and the player is the target of the camera. So this explanation is kind of meh. So what happens if I say init and the offset it's like 0, 0, for example? What happens if I do this? Okay, I see. So it's, yeah, so what you're drawing, it's drawn on the offset. Okay. So we need to put it at the center of the camera. So I guess, like, it's not out of the box, I guess, but if you wanted to be able to go to the left or something, like, I'm not sure how. Like, I basically want, you know, like the typical platformer thing, like, it's like, there is like a square that is smaller than the camera, the screen, sorry, the window. So it will be like from here to here, something like that. And you can move freely through that square, but as soon as the character is on one of the borders of that square, that's what starts pushing the camera, right? So you have freely movement inside, so you can jump stuff, but there is always like an offset from the window, and then that's what starts moving the camera. And I'm not sure how, like, if that comes out of the box, right? Or if it's something that you need to code on top of it, right? And they give you the basics, so maybe, you know, the rest is up to you, which will make sense. The next tutorial is platformer, so maybe we see some camera things in there, like, although I don't see it. Otherwise, like, it will be a good, you know, experiment to do that. Will be a good experiment. Yeah, so it says everything you are drawing, it's based on that target. Yeah. So you're drawing the player and the wall, and it's like the camera treats the center of the wall. It's basically this, and it puts that center of the wall, that target, in the offset, right? So it's like it's converting from one coordinate system into another one. Okay, that's cool. That's cool. So yeah, let's commit this, and I think that's enough for today.